My name's George Bew. It's May 6th, I think, 2016. I'm happen to be home alone with nothing else better to do, so I thought I'd just make a quick video to explain where gravity comes from. It's probably not a coincidence if you see a lot of correlations between what I'm about to tell you and what you may have heard from Bob Lazar many years ago. I did a lot of research maybe starting 15-20 years ago, and published a book and stuff like that, and then started watching YouTube videos and started coming across Bob Lazar's videos of his work and started seeing a lot of correlation. And so I think there's a lot of truth in the things he's saying, but I see some things that just look like they're not really exactly right. So I'm guessing it was disinformation, maybe not purposely on his part, possibly just people giving him information for his part of his job. We're not giving him the completely accurate information, just as a way of keeping as much stuff compartmentalized as possible. Anyway, here we go. It's really simple. You start off with an atom. We'll just do a helium atom here to keep it simple. You have neutrons, protons, and you have a couple of electrons. And they're moving around in their orbitals, or in their one shared orbital, with one of them with upspin and the other with downspin. Per Pauli's exclusion principle, they naturally develop upspin, downspin for each electron pair. And this is true no matter what kind of element you're talking about. How many ever electrons you have and however many orbitals. Their orbital motions are not like orbiting planets. If you're a chemist, you know all about all that stuff, the different shapes, the different orbitals. Regardless, they pair up, upspin, downspin. In reality, what they call upspin, downspin are axes of precession, and there's actually the actual spin axis is at an angle, and it precesses around, kind of like a gyroscope. And both of them do this. And classically, this is why they do it. Has to do with relative motion and magnetism. Anytime you have relative motion, it causes a magnetic field, a relative motion between electric charges. It causes magnetic field to be manifest from the point of view of one charge versus the other. So from an outside point of view, we don't see it, but for an electron whizzing around in various motions, classically speaking, since ultimately, although it's not accepted right now, the classical way of describing things actually does work if it's done correctly. So I'll just describe this classically. If you have an electron whizzing around and you have protons, let me take a break, get a better marker. You have protons in the nucleus. Per helium atom, you've got two of them. So, whenever an electron's moving relative to this, then from the electron's point of view, there's a magnetic field. If the electrons moving this way. The protons, from its point of view, appear to be having a magnetic field due to the relative motion, and this is totally separate from the magnetic field that is already characteristic of a proton due to its own spin properties. I'm not talking about that magnetic field. I'm talking about the magnetic field that generates only from the electron's point of view due to the relative motion between the electron and the protons. The protons also see a magnetic field coming from the electron due to its motion from their point of view. However, it doesn't have much effect on these because their mass is so much more. The primary effect it's going to have is on the electron. So, as this moves around from its point of view, it sees a magnetic field, and the magnetic field has torque that it applies to the spin axis, which is not this precession axis. Quantum physicists love to point to the precession axis and say that's your spin up or spin down axis, and that is not true. That is your precession axis. Your spin axis is going to be precessing around, and the reason it does has to do with vector equations. I'm not going to go into the math. You can go online and research it, gyroscope and all that kind of stuff. But what happens is, if you have something that's spinning and you apply torque on it to try to twist it around, either gravity pulling on a top or a magnetic field pulling on the magnetic dipole through the spin axis, if the electron is spinning, and you have a magnetic field. Let me do it this way. You have a magnetic field and it's applying torque to that magnetic dipole through the spin axis. It does not just turn straight down and line up with this magnetic field. Instead, the torque applied to it causes it to have gyroscopic motion around that direction. So, the magnetic field wobbling around in this direction is going to be radiating electromagnetic waves. So, because, what's the best way to say this? First, north is pointing more that way, and then as this comes around, south is pointing more that direction. So even if the axis of precession stays relatively the same, this is going back and forth radiating electromagnetic waves. And if you have around the nucleus of an atom multiple electrons, we'll just show one pair. Let's say you have this electron pair, this one with up spin, this one with down spin. That's the precession axes of each. They really also have the real spin axis that's wobbling around, and this one's wobbling around. And a quantum physicist will tell you that we can just ignore that. These are compensated spins. You don't see it outside of the atom. Only when you have an unpaired electron will you see and be able to interface with that RF signal that's radiating from that gyroscopic motion. And that's what the field of electron paramagnetic resonance, electron spin resonance is all about. And when you go get an MRI, that's what nuclear magnetic resonance is. They do the same kind of thing for the protons. If you have an unpaired proton, you can access and stimulate that frequency and get a signal back from it if you're at the resonant frequency that it likes to wobble at already. So when you have paired electrons, supposedly, well, they all cancel out. You don't even see that. Well, that doesn't mean it's not there. You still have electromagnetic waves coming from both the up and down spin paired electrons in various orbitals around all atoms. The reason you don't see it is they tend to synchronize. And that's finally the heart of what this video is about. I'm about to tell you right now. It's all about how they tend to synchronize. So, what's the best way to say this? I'm going to turn this whole thing on its side. We'll call this up spin and down spin for pair of electrons, and these are in orbitals in the same orbital around an atom. So this is the actual spin axis. This is the actual spin axis, both of them wobbling around. So what happens is they tend to, they will precess at the same frequency, and the phases are such that they are similar to two bar magnets. I'm talking about only that vector of its magnetization vector that is going to be going around this way. I'm not talking about the precession axis. There's another portion of the magnetization vector in that direction also, and that's not what we're talking about right now. We're talking about only the portion of the magnetic field that's going around. So imagine all that sideways for two electrons. That magnet, let me show it like this. Here's your up spin, and here's the real spin axis. That's the axis of precession. Down spin and its real spin axis, and it's going around like that, and this one's precession around like that also. Okay, so we're going to take this whole thing and turn it this way, and that's what this and this are. They are the vector portion of this and the vector portion of that are both facing that direction. So now that's the up direction. So they precess at the same frequency. So I'm going to draw them overlapped. Once per revolution, they're both pointing up. As they continue, another marker's giving out. Let me get another marker. I'm making all these mistakes so people who think they know it all already will get tired and give me bad feedback and stop watching. The rest of you who really want to learn something, you can keep watching. Okay, so they're both pointing up, they're both precessing at the same frequency. So once per 360 degree turn, they're up. 180 degrees later, they're both pointing down. And in between, they're going like this. One's going one way and one's going the other. Everything outside of them, this north, that magnetic north, rotating this way. This one's rotating that way. This one's rotating this way. So everything outside of here, if you remember, if you have a magnetic field pointing one way and it's moving another way, then it applies an EMF on charges the third axis, the third direction. So this is pointing down and going this way. It'll push charge in and out of the blackboard, and this one will push charge in and out of the blackboard the other way. And so it tends to make an EMF that's trying to make a current loop going around this way for electric current. And that's the maximum amount of EMF is when they're in this direction. As they spin on around and are both pointing down, you have a minimum amount of EMF. However, you have a maximum amount of a north. That north is rotated down, it's pointing down now. So it's like that. So what happens is, when both are pointing up, you have a maximum magnetic field, and the electric fields, the EMFs, are canceling out. The same amount of force trying to push one way gets canceled out by the EMF force trying to push it the other way. As they rotate in opposite directions around to this angle, the EMFs are such that they're trying to make a maximum amount of current flow looping around one way or looping around the other way. As they rotate past here and they flip around the other way, coming back up north again, they're going to be trying to give maximum EMF the other direction. So what happens is, twice per cycle you'll get a maximum EMF trying to make a current loop in this direction, and twice per revolution you have a maximum north pointing up, and then a maximum north or up, and then a maximum north pointing down. These signals, although we don't see them because we don't usually have equipment designed to pick up AC magnetism with the electric field portion canceled out, we don't have equipment that usually designed to pick that up, so we don't see it, and it pervades even the atoms of any test equipment you might try to use, so it's not an easy thing to see. So nevertheless, that alternating magnetic field's radiating out from all atoms, and the frequency is dependent on how they move around in their respective orbitals, how many positive charges are in the nuclei, causing a magnetic field from their point of view, which affects their Lamar frequency. That's that frequency of precession. The bottom line is, if you have an accumulation of mass, like in the Earth, all those alternating magnetic fields interact between similar orbitals of all the electrons within that mass, and it does so in such a way that those alternating magnetic fields are radiating out in this direction, in all directions, like that. Going north-south, north-south, north-south at extremely high frequencies. And if you remember, I said twice per revolution, precessional revolution, these will be trying to create an EMF, to create current loops in this direction. So going in and out of the board, and if you sum that all together across the surface of a sphere, they're all neutral. You don't see it. You might see some noise that could be interpreted as background noise, but you don't really see huge current loops going through the Earth, because the vector summation of all those synchronized, they're all synchronized, but small loops all over, all going the same way at the same time around the Earth. When you do a summation of that over a spherical area, it all tends to neutralize. So the big effect that really matters is twice per precessional revolution you get all these magnetic waves that are coming out of matter, whether it's Earth or anywhere. So the conjecture that I'm making is that what Bob Lazar calls gravity waves A and B really do exist. It's not the same thing as when you have like a star that collapses in on itself or goes supernova or whatever, so you have suddenly a huge change in the position of mass, and the gravity wave created by that propagates out in the space. That's a gravity wave describing kind of a step change in how much gravity from a certain location, and that ripples out. I'm not talking about that kind of gravity wave. I'm talking about the actual AC magnetic flipping polarization directions that comes from all atoms, electrons from around all atoms that radiate out, and they synchronize with each other. These push and pull on similar paired electrons in all other atoms, and so the tendency is for them all to become synchronized with each other and their magnetic vectors to sum together. And it gets more complicated in that there's not perfect harmony, perfect phase synchronization. There's actually spin waves. It's kind of like thermal noise within these sets of magnetic waves that all tend to sum together for large bodies of matter, or any mass. You know, they sum together and create the effect we know as gravity. And yes, gravity is a warp in space-time, and the only difference really is you can think of electric force as a warp in which it's a proportional amount of warp in both time and space, whereas due to the way they interact with each other, it's disproportional warp for gravity, and so then it manifests itself. I mean, it's still there for an electron, but we just see it as an electric force pulling on other electric charges. But due to the way they interact with each other, it's disproportionate in time versus space, and I know that all sounds wacky, but it's really, there's hardly any difference at all. It really is just a warp in space-time that causes gravity, and there's a similar kind of a warp that's causing other forces, like primarily the electric force is what I'm trying to say. So they're very extremely similar. Okay, so if by some miracle you grasp all of that, then there's a second, much higher frequency, similar precession if you have protons and neutrons in a nucleus. The helium nucleus, 2 protons and 2 neutrons. So what we are told all our life is the nuclear strong force holding them together. Just imagine the particles, the quarks that make these up, are precessing also and interacting with each other. If I remember right, quantum physicists in quantum electrodynamics, they call them gluons rather than photons. As the gluons is electromagnetic, or the gluons is not, they don't call it electromagnetic, but they call it the force carrier that of the nuclear strong force that binds these together. But you really could just think of it as extremely high frequency electromagnetic waves, and that would be more accurate. It sounded crazy when Bob Lazar said that, but he's actually right. It's just they precess at much higher frequency, much more short or close range interaction. We don't see it from outside the atom because it's all compensated for. If you have an odd number of protons, there's a signal there probably, but it's such high frequency maybe in the terahertz range, maybe up in the range of gamma rays, because it's a much higher frequency precession, and the signals they exchange with each other, binding them together, and also a portion of it radiated out into space, and all similar protons and neutrons will synchronize their motions due to the receiving the signals. So basically it's kind of like the same kind of interaction that's going on with paired electrons, but a much higher frequency for the motions of quarks within the nuclei. And that is what Ernst Mach alluded to, as there's some kind of interaction going on between matter and the whole universe, otherwise you couldn't have inertia. And just do a quick review of that, what Ernst Mach is talking about. If you imagine a man in a space suit and he's holding a couple of buckets. That doesn't look like a bucket. Holding a couple of buckets, and the buckets, there's your handle, there's your bucket, here's your handle, there's your bucket. And I won't say he's got water in him in outer space because it would all evaporate. Let's say he's got some sand in his bucket and sand in this bucket. And if the universe spins around him in this direction, somehow the universe spinning around him causes the buckets to be pulled out away from him. If you're watching him and he's perfectly still, then that really means, from your point of view, the universe is spinning around you also. So relatively speaking, another way to say the same thing, if you and the guy you're observing are both, if the universe is not moving, but you're watching this guy and from your point of view he's spinning, then there's a force pushing his buckets. I'm a terrible bucket drawer. Here's his buckets of sand. There's a force pushing his buckets out if he appears to be spinning from yours and the universe's point of view. But if you say the universe is spinning and he's still, and you are still or not, either way you're observing him, if he appears to be still and the universe spinning, that force is pulling him out. But if he's still and he's still relative to the universe, there's no force pulling the buckets out. So Ernst Mach making that observation where you say it's out in space or on Earth, wherever you do the experiment, you know, you can do it whether you're in a gravitational field, he's standing on Earth doing this experiment with weights. If he's spinning, there's a force doing this. It's no dependence on the Earth being here or not. It's going to happen whether he's on Earth or in outer space. If he's spinning relative to the universe, something makes a force pushing him out, even though you could be, along with him, in relative stillness, not moving at all. It could be the universe is spinning, and the fact that that's happening will cause the force to go out. So Ernst Mach saying, well, that's impossible unless there's some kind of interaction between him and the universe. Somehow the universe has to know he's moving, or he has to know the universe is moving, in order for that force to get generated. So my conjecture is that ultra high frequency precessional waves, precessional motion generated waves coming from atomic nuclei